Welcome everyone. Today we'll be talking about chemical monitoring and management with a focus on haloalkanes and isomers. And in this lesson, we'll be talking specifically about what haloalkanes and isomers are. So here we have a propane group. So there's 3 carbons and various other bromine atoms attached. And so in this lesson, we'll try and develop what isomers are and how these sort of structures relate to isomers and haloalkanes. So if you can already determine what an isomer is, then that's great news. But for those who can't see from this picture, this is what this lesson is all about. So firstly, we'll talk about what a haloalkane is. So a haloalkane is simply an alkane. So remember that alkane from production of materials is simply just a carbon chain with only single bonds, where one or more of the hydrogens has been replaced by some kind of halogen. Now remembering that halogens are group 7 elements, so fluorine, chlorine, bromine, or iodine are the main 4, but there are of course others in group 7. So if we look at this molecule here, we've got 3 carbons, and instead of having a hydrogen connected, we have a bromine atom connected. And of course this is to scale, so bromine is much larger than carbon, so you get this very large bromine atom attached, rather than a very, very small hydrogen atom. So a natural place to go next would be to how do we name these things, because otherwise we won't be able to communicate with other chemists about what we're actually seeing. So what we need is an abbreviated halogen name. So in order to identify what halogen is actually part of the molecule, we use abbreviated prefixes. So the prefixes of course indicate what halogen is there. So for instance, if there's a fluorine, we call it fluoro. And if there's chlorine, we say chloro. Bromine is bromo, and of course iodine is iodo. So if we take that naming convention over to this molecule here, there are carbons at these points. And so we have a chlorine group, a bromine group, and 3 fluorine groups. So what we say is 2 bromo, so bromo being bromine, 2 chloro, and remembering that the 2 is simply just a sort of carbon number rather than any sort of numerical value. It just tells you which carbon we're talking about. And 111 tri, obviously 3, fluoro, because it's fluorine, and then ethane, because there's only 2. So that's how we use this naming structure. And we'll have more examples as we progress through this lesson. But for now, we just remember these 4 naming groups. Now remembering, numbers identify the position of the functional groups. Now the question then becomes, why is this not 2, 2, 2, 1, 1? Well, remembering that from production of materials that we try to make the numbers as small as possible. So having 3 2s is obviously bigger than having 2 2s. So that's why we put the fluorine groups as number 1 rather than number 2. And these numbering systems help us to distinguish between isomers. And we'll talk about what isomers are in a few moments. So more examples from this system of naming. So here we've got methane, because there's only 1 carbon, and we've got 1 iodine group, so it's iodomethane. Now the next question is, why don't we say 1 iodomethane? Well, a typical example of that is because there's no other way to say 1 iodo, because there's no other carbons that it could be attached to. So when there's absolutely no ambiguity, we can use just simply iodo rather than putting a number there. And because there's only 1 carbon, of course you can't say that there's other carbons there, so this is fine. So here we've got CH2Br2. So there's one carbon again, so it's methane. Then it's, so methane being one carbon. And there's bromo groups because there's bromine. And then, of course, because there are two bromo groups, we have dibromo. So moving on to a more difficult example, let's have a look at this one. So all of these are fairly self-explanatory. If you follow that naming structure, you won't have any problem with the naming of these. But as an example and as a test of your own skill, try and go through each of these and just justify to yourself why they're named the way they are. So with this one, we just count the carbons first. So 1, 2, 3, 4, 5, 6. No, sorry, 5 because this is a chlorine. Sorry, so 5. There's a double bond, which means that it must be an ene group. So it's 5 being pentene. There's one chlorine, right? So this chlorine is on the 5th carbon. So we say 5 chloro. The double bond is on the 2, the 2nd carbon. So it's 5 chloro, 2 pentene. So moving on. So again, this one, again, a test of your ability. So if you can justify to yourself that this is named the way it is named correctly, then that's a good test of your skills. So moving on. So how do we actually name these things? We look back at production of materials and we follow the same steps, but we'll recap for those who may have forgotten or who are just studying this for the first time. So firstly, find the longest carbon chain. So in this case, 1, 2, 3. So 3 means prop. So look back on your notes to find out what all of the prefixes are. So this is prop. Give the lowest possible set of numbers to the halogen atoms present. Okay. So remembering when I talked about the other example right at the start, where it was 111 trifluoroethane rather than 222. And the reason is we try to keep the numbers as low as possible. Now, if each end provides the same set of numbers, so for instance, if you look at it one way and then look at it the other way, and then so number it, say 1, 2, 3, or 1, 2, 3, then you give the numbers based on which one comes first alphabetically. So for instance, if there was a chlorine on this end, then we'd say, or if there was another chlorine group somewhere, bromo would come first because B comes before C. And we'll have examples of that in a few moments. And if different halogens are present, remember always list them in alphabetical order. So bromo comes before chloro, chloro comes before fluoro, and obviously fluoro comes before iodo. And then if there are more than one of the same functional group, for instance, if there are maybe 2 bromine atoms here in this compound, then we use the prefixes di, tri, pent, tetra, all of those other ones that you should be familiar with from earlier study. So 2 would be di, 3 would be tri, tetra, which is 4, not quad or anything like that, only derivative of quad, it's always tetra, penta, 5, hex, 6, and so on and so forth. So let's do an example because it's more clear when you sort of work through it. So first things first, we count the number of carbons. So 1, 2, 3, 4, 5, 6, 7, 8. Molecule has 8 carbons. So it must be octane. Oct meaning 8. Now, there's both chlorine and bromine attached to the 4 position. So if we count this way, we have 1, 2, 3, 4. So 4 for the chlorine. And also if we count this way, 1, 2, 3, 4, you get 4 for the bromine. So we count both ways, we get 4. So what we do is remembering that alphabetical order is the best way to do it. So we give the lowest number to the first one alphabetically. So it'd be 4 bromo and 5 chloro. So we give the 5 to the chlorine and the 4 to the bromine. Okay? So the name, final name, 4 bromo, so remembering the 4, 5 chloro, octane. Now if that's clear, we'll move on to the next example. So again, we go through the same process. There are 7 carbons, so count for yourself, there will be 7. So it must be a heptane of some description. So we say heptane. Now, we give the lowest number. Remember, we're numbering them in the lowest possible way. So we count 1, 2, 3. So the first one, chlorine is at 3, bromine is at 4. So what if we count the other way? 1, 2, 3, 4, 5. See, now we have a situation where chlorine is 3 in one direction, but it's 5 in the opposite direction. So remembering we always, keeping the numbers as low as possible overrides alphabetical order. So we say that it's 4 bromo. We list them in alphabetical order, but the number is lower. So 4 bromo, 3 chloroheptane, because 3 and 4 are much smaller than 4 and 5. So, but we always write in alphabetical order. So even if the numbers are out of order, that's okay. 4 bromo, 3 chloroheptane. Now, isomers, structural isomers in this case. So haloalkanes with more than one carbon atom exist in isomeric form. So methane doesn't have any, has no isomers because you can't rearrange the chains in any meaningful way because there's only one carbon. So let's say we look at normal butane. We've got 4 carbons in a straight chain. But if we look at isobutane, you've got 3 in a chain plus an additional methyl group. So they're compositionally the same. There's no difference in what puts them together, but their structure is very different. So what is a structural isomer? Compounds with the same molecular formula, but the atoms are of course arranged in different ways to form different molecules. So another example would be if we have 1 bromopropane. See how the bromine is attached to the first carbon? Obviously we're counting 1, 2, 3 in that direction. Whereas in this case, the bromine is attached to the middle one. So we call it 2 bromopropane. Now what that does is it gives these slightly different molecules different properties. Of course they have different structural formula, as you can see. One obviously is different to the other. And so a molecular formula for bromopropane is this, C3H7Br, but it can give you 2 at least different structures in total. So an example of a structural isomers, there are many that are possible with C5H11Br. So this is some kind of pentane. So we'll draw 3 simple structures for them. So the first one, it's attached to the first carbon, so we call it 1 bromopentane. There you go. So now it's connected to the second carbon, or it could be the 4th carbon, but remembering we always keep the numbers as low as possible. So we say that this is 2 bromopentane. And lastly, we have, now it's connected to the 3rd carbon in either direction, so we call it 3 bromopentane. So these are 3 very simple isomers of this equation, of this molecular formula, but they give you, of course, several different types of structural forms. So, practical investigation that you should do in your high school, but we'll just have a quick overview of it now, is modeling these haloalkane isomers. So, with molecular model kits, those little ball and stick models that you have, you can construct different haloalkanes with different numbers. So place the halogens on different carbons, you would have made different isomers. Okay? So of course, like I just mentioned, if you keep changing where the where the halogen goes, of course, the new molecule is completely different to the previous one. And isomers always have the same molecular form, but the atoms are always differently arranged. So, for instance, if you keep moving these around with different chemicals, then there'll of course be different molecules. So this concludes this section on haloalkanes and isomers. So what we've talked about is what are haloalkanes, how do we name them, and what is the proper naming convention. And we've gone through some examples relating to how to name them correctly. And then we've finished with what are isomers, how do we name them, and what are some of their properties. And we finished on this practical investigation. So moving to some practice questions, because naming things is, particularly in chemistry, is a very important topic. And so we'll hopefully try and reinforce all that knowledge that we just developed in the previous 10 or 15 minutes. So question 1, name this molecule. Now, there's a temptation. So first, we list the longest chain of carbons. So 1, 2, 3, 4, 5, 6. Now, there's a temptation here to just say it's 5, because this one's off to the side. But remembering that this is still a chain, even though it's bent. So it's actually 6. 1, 2, 3, 4, 5, 6. Okay? Now, if that's clear, we move on. So we know that it's at least some kind of hexane group. Now we look at the functional groups, Br and Cl. And then we say, well, in which direction do we get the lowest numbers? So 1, 2, or 1, 2, and 3, or 1, 2, 3, 4, 1, 2, 3, 4, 5. So with this, of course, counting this way is lower. So we have 3 bromo, 2 chloro, hexane. And there's your answer. Remembering that we name things in alphabetical order, but even if the numbers are out of order. So moving to the next question. Draw the structural formula for this molecule. Okay? And the way to do that is to start with the end. So that sounds kind of counterintuitive, but it will help you develop this diagram much more easily. So we start with ethane, or ethane, which is, of course, 2 carbons long. So we start with 2 carbons. Here we go. And ane, meaning there's only single bonds, so it's only a single bond. Now we look at the functional groups, and let's say we look at difluoro first, because we're going backwards in this case. Difluoro and 1 and 2. So there's 1 fluoro here and 1 fluoro here. And of course, the same thing applies to the chloro. So we have 1 fluorine, 1 fluorine, 1 chlorine, 1 chlorine. And then the only thing left to do is to simply fill in the remaining bonds with hydrogen. And that is the structural form for 1,2-dichloro, 1,2-difluoro, ethane. So again, moving to question 3. List the 4 major halogens from the periodic table. Now all you have to do to answer this question is look down Group 7, and that will be the answer basically to this question. So that's Group 7. Fluorine, chlorine, bromine, and iodine. So those 4 chemicals are the main halogens in the periodic table. And question 4. Define the term haloalkane. Now remember, define simply just means to explain what that means, or tell us what this word means. And so an alkane with 1 or more halogen atoms in place of hydrogen atoms, or atom. So we replace one of the hydrogens or more with a halogen, and that will be a haloalkane. So very simple question. And the last question, question 5, list the prefixes used to identify halogens present in a haloalkane. So, of course, remembering the earlier parts of this lesson, all we have to do is list fluoro for fluorine, chloro for chlorine, bromo for bromine, and iodo for iodine. So this concludes this section on haloalkanes in chemical monitoring and management. So hopefully you've learned about what a haloalkane is, what a isomer is as well, and we've done a lot of examples relating to how we name these things, because that is the main part of this topic, how to name these haloalkanes and isomers. So next lesson will be a lesson on chlorofluorocarbons and halogens. So I look forward to seeing you at the next lesson.